Ooh, this meeting is being recorded. Nice. Okay. So the question was, how are we going to take exams? Will our computers be encrypted? No, they'll just be infected. You got to use your verbiage right. One of my colleagues suggested doing an assignment in which you guys can, quote, turn it in, which means between exams or labs or homeworks, the idea here is that you could make some sort of Word document or take a picture and then make a PDF out of that and upload that through Canvas to, quote, turn in the assignment. That way I can go through, click on your assignment, read through it, assign a grade. So yes, for the first time, I get to do grades in Canvas. Yay. So I get to figure that out. It's probably not that hard, but it's annoying. Exams. I haven't quite figured that out. The first thought that I have is maybe posting an exam online and having you guys take it, take pictures, PDF it, and turn it in. Because I don't know, there's basically no way that I could think to make a quiz in Canvas, a test in Canvas that makes any sense. So unless I can, go ahead.
I know before Castro would do the online exams, and it was like, I think you had to do multiple choice, but then when we were in class, he would have us turn in our work. I don't really know how that would work with.
Yeah, we are probably not coming to class. I would lay a ton of money that we are not coming back the rest of the semester.
Gotcha.
Given how a lot of the UCs and CSUs have gone to the end of the school year, and even some K through 12s have said that around the state, around the nation, I think it's probably a matter of time before they just announce that for us. We are going to reevaluate in 3 weeks, but all signs point to this is how this is going to be. That's not anything official. That's just a gut feeling. I agree, McCann. Whoa. Labs. So Hanson and I went through and did just about every lab for you. We videotaped ourselves doing it so that we can post that and then have you guys do the post-lab questions and or plot up anything for data. I'll come back to that lab 5 idea, Chef. Give me a second. So for instance, I did the magnesium with hydrochloric acid. Breather there.
We're getting like a lot of car noise from somebody.
Yeah, who is that? Uh-oh. Let me go back to them. Who is that? Let's stop the sharing. Who's making all that noise?
I think it's iPhone.
Who's iPhone? iPhone, talk to me. Well, iPhone. iPhone. Well, I'm going to mute iPhone for now. And I think I'm muting iPhone. I have the power. At least I thought I did.
You haven't muted them yet.
I'm trying. Maybe I don't have the power. Where did iPhone go? Did iPhone just leave? Everyone keeps moving around.
Yeah, we're down to 28.
Okay, so we actually lost 2 people. I don't know who else we lost. Whoa, Isa, easy. Oh, second Lion Lee. Oh, it was probably iPhone. Okay. So back to what I was going to show you guys. we did the magnesium heat event enthalpy that you guys will do when we get to thermo. And so we actually got a whole bunch of data that I plotted up and did all this with. You guys can see the plot here. Uh-oh, no, anyone?
Yes.
Yeah, we
Okay,
see
good.
it.
Okay, good. So essentially what it is, there'll be a video, and if there's any data we collected, I will actually be posting that for you guys to use, and then it'll be up to you guys to do the analysis and answer the post-lab questions. There's no point in the formal labs because you weren't there. You know, without the physical experience, there's very little you could probably do to make a viable report, because you kind of have to have that physical experience to do it. So, and then someone asked about the labs, you know, lab 5 and things like that. Again, what I think I'll do is create an assignment in Canvas to which you will take pictures or something and make a PDF out of it. If you don't know how to do that, I'm sure one of your colleagues does. Or I can also try to figure out how and to walk you through it if you need that help. Ooh, más preguntas. How much do I need to know for the, is that, oh, nice. I didn't even have to get to the end of that one, Tanaris. Word document does work, Dallas. I'm totally fine with that. I only said PDF because PDF, but yeah, you can do Word document. That's fine. Homework. How about I just assume you're doing it? I mean, I got nothing better to do. As I put on my Chem 110, I met with a few of them a couple days ago, and they're like, well, there was a suggestion that they could take a video of them like flipping through it, and I said I could think of better ways to kill myself than to go through 70 people's minute video longs of their homework. So I'm just going to assume that you've done your homework. I know, Dallas, that you like that. So let's see. I'm going to go back to OneNote. You guys are still there with questions. Any other burning questions before I attempt to do this thing? Hearing nothing, seeing nothing. Oh, that is not going to get old. Actually, real quick, let me go back real quick. I do want to see something here. Raise your hand if you've taken an online class. Oh, man. Wow, that's a lot of people who've taken, holy crap, that's like most of the class. Then I have a question. Did they ever do this, or did you just watch the lectures? Keep your hand up if they did a live lecture.
I don't know how to take it down.
I think you just tap it again. So, wow. So basically only different. So I'm going to be your first live lecture.
Normally they just give reading
Except for
material.
Chem Chief. Oh, man. All right, well, here we go for the non-boring version of online instruction. Okay, do this. We'll come back to OneNote. There we go. Ooh, look at this. I have a cool little title up there, Continuing Titrations 319. I assume you can all see that. And I guess they were all readings and documents. Yeah. So hopefully you'll find this a little bit better than just some mindless voice talking to you. So last time we did the hydrogen cyanide titration. I want to do another one here. It'll be another acetic acid, but I want us to generate it, and then we're going to do something cool. We're gonna keep building as we always do on each of these problems. So, all right, here we go. So we're gonna do another example. That example is going to be draw a titration curve.
You might want to zoom in.
Oh, might want to zoom in? Really?
Yeah, your handwriting's
Okay.
still a little.
Draw a titration curve. I'm going to go ahead and make this. Let's go with 60 mils of 0.8 molar HAC with 0.6 molar KOH. And here we'll have a Ka equals 1.8.
Can you zoom out a little bit? That's way too close.
Yeah.
That's way too close?
Yep.
How's that?
That's good.
Okay.
Better. Thank you.
Oh, look, my internet connection is unstable again. Yay! Oh, all right. Now, when we do this problem, the first thing we want to do is to get that endpoint so we know where we are. Notice that I left it open-ended. I just said you're going to titrate it, so you don't know when to end. So the first thing you need to know is where you're going to end. Do you guys remember how we figure that out?
Are you
The M1V1?
That one was going to be the M1V1. Yeah, I'm going to try to do this as much as a normal lecture is possible, or just speak out real quick. Don't be shy. Yeah, it is that. Let me erase that and say we need to get that endpoint. So first, ooh, wow. First, get the endpoint. So now I see what Boudica was saying. If I zoom in, I can make it look normal. If I zoom out again, I can only get like 5 words across the page.
So it will be something where you're gonna have to zoom in and then like as you're talking about it, zoom out so we can all see it.
Okay. Let me try that real quick then. Because otherwise, when you guys get the PDF, I think it's going to be ridiculously big. So I need to say, first, get the endpoint, which is going to be, because we can, it's going to be that M1V1 equals M2V2. And remember, we can do that because we're always going to get rid of one H at a time. Right now, they're all single acids or monoprotic acids, so it's intuitive. But when we get to the diprotics and triprotics, I'll prove to you that we are only getting rid of one at a time. So we can do the M1V1, so we have 0.8 and 60 mils. So 0.8 molar and 60 mils is equal to, we had 0.6 molar, 0.6 molar, and we need to know that volume. So hopefully you see that volume is now 80 mils. So this is now our endpoint.
So if we have 80 mils as the end point, then we also know the halfway point, 40 mils. So that means that the halfway point is 40. Now, since we have that, we can immediately make our chart that we're going to make so we can plot the pH versus the volume and start building that up so we can do volume of the base and the pH that would result. So we can go 0 up to 80. So we can choose increments that would seem normal. The 10, 20, 30, 40. If we did every 10, we would have 3 points on either side of the midpoint. I would say that that's probably the bare minimum to try to get a decent curve. So why don't we go ahead and just try that and see how that looks. So we can go 10, 20, 30, 40, 50, 60, 70, and 80 mils. Okay, so we know that this 40 is the halfway and 80 is the end. At this point, these problems can be done in any fashion you want. And oftentimes I find that students will grab the quick points the fastest and then backfill as needed. So what's the first and easy fast points we can get? Halfway, that's right. So Dallas says the halfway. So the easy money. So easy fast points. This is going to be our halfway. Because I'm sure, as you guys remember, at the halfway, pH equals pKa. Wish I could shrink that down a little bit. That's about as small as I can get. All right, if pH equals pKa, we go back up. We'll look at that pKa of 1.8 times 10 to the minus 5. Let me make that just a little bit better. 1.8 times 10 to the minus 5. So now we say that pH equals negative log of 1.8 times 10 to the minus 5. And if we do that, we should end up with that 4.74 that we all know and love. Ooh. So now we have a red pen. Woo! I wonder if I can. Look at that. I'm fancy up in here. All right. Oops. Right there. So now we can go back up in here and we can put in our pH at the halfway point of 4.74. All right. First things first, how is this working out for everyone? Hearing that real quick, and I'm going to go back. Raise your hand if it's going, or give me a thumbs up, I should say, if it's going okay for you. And a hands up. Okay, good. So it looks like this is going okay. Again, let me know if I need to slow down, jump in there. Okay. Come back here one note. There we go. Okay, so first things first, we have those easy points that we can get. At this point, I usually try, and I know Dallas will probably jump straight to the Henderson-Hasselbalch, which is still fine. I do like to put the bookends though. So let's get the initial and the final points of our plot. Ooh, let's see, initially, ooh, I'll do purple. So the initial point. Okay, remember, initially, all we have in there is the acid, right? So this is only HAC. So our equation is HAC goes back and forth to make H plus and AC minus. We want to know our starting point, so of course this invokes the ice table. So we have our initial, our chain, oops. We have our initial, our change, and our equilibrium. And we just go back up and grab our initial concentration, which was 0.8. See right there. So we start out with 0.8 for the HAC, and we assume nothing of the other two. And then, of course, we go the minus X plus X plus X, which means we end at 0.8 minus X, X, and X. Hopefully by now you guys are all pretty much bored by this because you know where we're going next. We're going to make that ice table, and we're going to say that this all comes down to that the Ka is equal to the concentration of H plus times the concentration of AC minus all over the concentration of HAC. And we're going to go ahead and plug in our numbers. That is just, we'll have X and X over, what is it, 0.8? 0.8. 0.8 minus X, and that's equal to our Ka of 1.8 times 10 to the minus 5. At this point, what will Ariana tell me? Oh, that's who we're missing. All right, Ferris, you have to stunt double. What do we get to do? Channel your inner Ariana.
Ignore the X.
There you go. Ignore X, right? So at this point, and Sing, your voice got really deep there. You feeling okay? So, right, we ignore that X. So we are able to now just say that we have X squared over 0.8 is equal to 1.8 times 10 to the minus 5. X. If I solved it right, I have 3.79 to the negative 3. Confirmation? There we go. Oh, of course, Dallas. Thank you. Thank you, Ferris. So we have 3.79 times 10 to the minus 3. And of course, you know you're on deck. So Ferris, what is X? There you go, H plus. So this means that this is the concentration of H plus. Okay, and since we're going for the pH, that means we just now have to solve for that. So then the pH here, oops, I wanted that in purple. All right, the pH is equal to negative log of 3.79 times 10 to the minus 3, which Dallas will tell me gives me a pH of?
Yeah, that's what I got.
2.42. Okay. So this is 2.42 at the initial. So now we'll just go ahead and put that back into our chart. So our initial pH is 2.42? Yeah, 42. Okay. So now we need to have the end point. So now let's get the end point. All right, who do we have in here? Who can I call on? No. How do I just slide and tap? Chef. End point. What's going on at the end point? You can unmute yourself and talk away. Yes, it is all base. I like how no one wants to be recorded on this thing. It is all base. So that means we only have the AC minus left. We only have the AC minus left. I can write better than that. Remember, even though it looks like a pen, I can erase it. Oh man, my kids are like that. Hey, Daddy. All right, so, Boudica, see if you can you overwrite on this?
I never figured out how to.
Dang it, all right, shoot. Oh wait, no, hold on. I think I can try this. There was like a blackboard we could use. I will figure that out. There was a thing that we did once. Oh, whiteboard. There we go. Can you write on it now?
No.
Dang it. All right. So let me get rid of the whiteboard here. Where did I see the whiteboard again? Oh, it's when I did this. Well, we have the whiteboard now. There's a thing, I'll look into it, guys. I apologize. There was something that I was able to do once where there's an overlay where you guys could actually try to write something on there if you happen to have a touch screen where you could do this. So I'll look more into that where I could say, hey guys, what's the equation? And someone could actually write over me. So I'll look into that in the future. So I'm going to pretend that Chef, let me pull up my chat window wherever it went. Where'd my chat window go?
You want to share your screen again?
Oh, I didn't? Oh, oops. Thank you. Thank you. Are we all back now? We can see the
yeah, we're good.
Thank you, Isa. So, okay, so until I get that whiteboard going, I'm going to assume that Chef said that it is just AC minus plus that H2O. Goes back and forth to make HAC and OH minus. Can I zoom out while you're talking so you can see the whole thing? Absolutely. Keep reminding me to do that. Still getting the hang of this. So just to recap, we went ahead, we got our easy way with the halfway points. Now we're working on that initial point and the end points to sort of get us going on. The initial point, it was only the acid. We set up our ice table. We went ahead and solved it like we normally would. The end point, Chef says we have only the AC minus left. We go ahead and set up the base equation now. And once again, we'll set up our ice table. So we set up our initial, our change, and our equilibrium. But what is our AC minus? Where does it come from? Yes, it comes from the HAC, and specifically the initial HAC. Thank you, Isa. You guys can actually talk. It's okay. It comes from the initial HAC, But remember, we're going to have a total volume at the end now because we've essentially been diluting it the entire time. So scrolling back up here, we see that we started with 60 mils of 0.8, and we have to get the final volume. So we have 0.8 moles of HAC per liter of HAC, and we had 60 mils, so 0.060 liters of HAC. Just reminding us that 1 mole of HAC will give you AC minus. And now we need our final volume. So our final volume, just to remind us, we started out with 60 mils right up here. And we ended by adding 80 mils of our stuff for a total of 140. Ooh, can I undo that? So we have 140 total or wrong. Or 0.140 liters of the solution at the end point. Dallas, number.
Well, I got 0.34.
0.343?
0.343.
Yep,
Yeah.
I like it. 0.343 molar for our AC minus. Now that is going to go back right back into here. And again, 0.343. We don't care about the water. And of course, HAC and OH minus, we assume to be 0. At this point, hopefully you guys are ahead of me, and you will just say minus X plus X, because everything is 1 to 1. And we get 0.343 minus X, X, and X. Now, at this point now, we do know this, by the way, is governed by, it's governed by a KB, right? So when we do this, we know that the KB is equal to the products over the reactants, and our products are HAC and OH minus all over that AC minus that we started out with. But what's KB?
5.56 times 10 to the negative 10.
Right, 5.55 to the negative 10.
Yeah.
But what is it? How did you get that?
Ka times Kb equals Kw.
Right, so it's the Kw over the Ka. So we just want to remember that even if I give you one, you can always get the other. So that is, oh, there's a slight pause when I do this. 1 times 10 to the minus 14 divided by 1.8 times 10 to the minus 5, which is 5.55 times 10 to the minus 10. Okay, I'm actually going to go over here. I'm going to get rid of this because I think this is getting in my way. Oh, there we go. A little more room now. Okay. So now we just go ahead and set that up. We know that HAC is X, OH is X, the AC minus is 0.343 minus X, and that equals 5.55 times 10 to the minus 10. Ferris, what can we do with X? Neglected. Very good. All right. So again, that goes away. So we end up with x squared over, oh, sorry, wrong thing to neglect, sorry. We're neglecting x. So we have x squared over 0.343 is equal to 5.55 times 10 to the minus 10. Solving, x equals, according to Dallas, 1.38 times 10 to the minus 5. Nice. Everyone's like, we don't trust you, Dallas. We are confirming. I like it. Hey, Ferris, what's x? That is correct. That is the concentration of OH minus. So, now that we have all that to get the OH minus, that's not how we get pH. All right, Lim, do you want to tell us how you got that H plus being so, by the way, negative 10, not positive?
Oh, yes. Sorry, negative 10. If H plus times OH minus equals 1 times 10 to the negative 14.
That's right. H plus times OH minus is equal to 1 times 10 to the minus 14. So our H plus is equal to 1 times 10 to the minus 14 divided by that 1.38 times 10 to the minus 5. And
Just make that yeah.
7 point, what is that, 24? Times
Yeah,
10 to the
24.
10, so that's a concentration of H plus. Which means we will now get our pH. So our pH is equal to negative log of 7.24 times 10 to the minus 10, which you're going to tell me is equal to 9.14 at the end point. Now keep in mind, I want to point out, and Tanaris, am I zooming out enough for you in between?
I think the
I'm
Zoom
assuming
makes.
deafening
I
sounds.
think. I think the Zoom makes it hard to keep up, and then by the time you're zoomed out, we're starting to move forward, so you can't even get all the stuff down. But
So-
is this all being uploaded later?
Yes, it'll all be uploaded later, but feel free to slow me down.
Okay.
I don't know how fast is fast. So yeah, absolutely feel free to be like, zoom out for a minute, slow me down. Remember, the slower we go, the less we get to cover.
Yeah.
I'm
Yeah, I
just
get
kidding.
that.
I'm just kidding. We'll still get through everything. Let's see. So we have our end of 914. Let's go ahead and go back up to our chart and let's put that in. Okay, so now we have our bookends, and now we just have to fill in the rest. Before I do that, I guess maybe I should point something out. And I'm surprised that Lim, Dallas, even Tanaris, because he likes shortcuts, Harvey, because he just sees in numbers, that a pattern hasn't been established that you guys can raise your hand and go like, well, yeah, in Henderson Hausbach, we're coming there. No, there's a shortcut actually that will save us even more time on exams. If you notice the initial point, we make an ice table, right? Okay. And it's always the concentration of the acid minus X and X and X. That's never changed. If you look back in your notes, you'll see that it's always something like x squared. Let me just put this. Let me circle it in teal. It always ends up right here as sort of an x squared over the acid minus x. And that, of course, equals Ka. Now, I'm going to go ahead and erase that because on the PDF that I make of these notes, or actually, no, I can leave it up because it's just a video, right? Or am I also going to put, do you guys want the PDF of these notes too?
I feel like the PDF would be better because that way we can look at the whole thing.
Okay, then I'm going to undo these teals so you don't go like, where the heck did those things come from? They'll be in the video. So, Sadell says, I wasn't sure if that was a coincidence or not. Yeah, actually, for once, guess what? It's not. Every time we do these, you'll find out that both for the initial and the endpoint, you see this x squared over something minus x equals their equilibrium constant. So, all right, note. I'm gonna zoom in just a little bit, make my handwriting a little bit better. Every time we did the initial and endpoints, the initial and endpoints, it ended up being, ended up being x squared over a minus x equals Ka for the initial, and x squared over b minus x equals Kb for the end.
I have a question.
Oops, let me get rid of that. Okay. Ask it. Yes? Uh-oh.
Is it, yeah,
And who is
it's kimchi.
Hey, Kimchi.
For the base one, the end, I guess, the B isn't the concentration of the base though, right? It's like the concentration of the acid
The conjugate
in
base.
total volume.
Not the acid in total volume, it's conjugate base.
Okay.
And so that is the thing. So I am going to go ahead and note there here, A is the initial acid concentration. No calculation. The B here, the B is the conjugate base concentration. Oops. Zoom in to try to make it the same. Conjugate base concentration. Calculation needed. Calculation needed. The total volume. Yeah, that is a distinction that sometimes gets lost in the shuffle as we go fast, as we learn these shortcuts that I've hopefully proven for you time and again. is that you do need to get that conjugate base. And of course, as Ferris will remind us, essentially 90 some odd % of the time, you can ignore X. I leave it in there as the full proper way of doing it. But for the most part, you almost can always ignore X in these. And of course, remember that KB is equal to KW over KA. Okay. Well, that's exciting because when we go to do the next ones, we can actually really start zooming even faster. So now we're just going to try to get those in between points. So all points in between. Points in between. That is going to be Henderson, Hasselbach, as Tristan pointed out. I believe it was Tristan. It might have been Garrett. And so as we recall, that is pH equals pKa plus log over X of X over A minus X. I can keep going to the left. This is, oops, a little too far. Moles of acid. And X. And I cannot write across the check box. All right. And I can probably write increment. Oh, what's this? I just want to point out something really cool. Not that it's that useful because of all the things I do here. Oops, hold on. Yeah, that didn't work very well. Oops. So you're just gonna have to deal with my handwriting. Oops. Okay. So now we just need to figure out what A and X are, and then it's a little plug and chug. It's so weird. It's so quiet. I should have recorded you all like jibba-jabbing in the background so I could play it. Right? Crickets. Oh, that's what I should play in the background. Just a bunch of crickets. Only this time I can't be like, come on, guys. You get like 10 weeks here. All right, so.
That's so funny.
Let's get A. So what was our initial, was it 0.8 and 60 mils? Let's zoom out. Let's scroll up. Gal says, yeah, because he remembers everything. 0.8 and 60 mils, yes. Oh, wow, that's zoom out. All right, sorry. So A is 0.8 moles per liter. And we had 0.060 liters. So I think that's 0.48, 1 0 and a 4.8, I guess. Yeah. 0.048 moles of acid. That means now we just need to get X. Now, X, we chose a 10 mil increment, and it was a 0.6 molar, if I recall correctly. So that's 0.6 moles per liter. And we chose a 0.010 liter increment. So that's 0.006 moles of base. Norris, how's that working out for the zoom out and everything?
I'm just gonna write this problem out later. I'm just following along now.
Is anyone still writing as I'm going along? Ooh, I can stop sharing real quick and go look at hands. Hold on. Anybody still writing? So Boudica, Ferris, Kyra, Durkin, Alexia.
I don't think
Okay,
you
so
ever
plenty-
took her hands down from before.
All right, everyone, I'm going to take your hands. Say it again and like, you're like, yeah, no, we're all just watching.
Wait, can you hear me?
Yeah, if you talk and unmute yourself.
Oh,
That's what I said. You can always unmute yourself and just shout at me.
I'm writing everything. I think I have a lisp though with this headset because I can't hear you over like the computer. I have to wear a headset.
Okay, that's fine. And Sadia, are you still doing it? Is that your hand up?
Yeah.
So Ferris is still writing. Alexia is still writing. Okay, so still a few. Are you guys doing okay with the writing? Do I need to slow down? Derek,
Keep on doing your thing. Keep on doing your thing.
Kyra was like, the pace is fine. You will allow this. Thank you for your permission. I like it. All right. You know, anyone like watching this YouTube video who didn't know that we all know each other would be like, this is weird. Like, how does he know all this? Or, I don't know. I just find it amusing. Imagine someone who didn't know us trying to keep up with all of our stuff. All right. Back to sharing. Back to OneNote. Okay, so let's go ahead and set up this Henderson-Hasselbalch. So we would say that at 10 mils, I'm going to go ahead and write out just a couple of them, and then we'll just go ahead and say we obviously know how to use our calculators. So we would say that pH is equal to pKa plus log of x over a minus x. And we know that pKa is 4.74 plus log of our first increment is 0.006 over 0.048 minus 0.006. And someone's going to spit out a number of, because I actually don't have that number.
A pH?
3.9.
Yeah.
Yeah, 3.9.
3.9. Okay. 10 mil. I'm going to go ahead and get the 20 mil, and then we'll put them up. So at 20 mils, I think we don't have to rewrite it. We can just say 4.74 plus log of 0.012. Remember, now we've doubled the base increment, so we can just take and double that x over 0.048 minus 0.012. And then you'll tell me that that pH is
4.27.
4.27.
Mm-hmm.
Okay. And then, not to put too fine a point, but let's just go ditto for all others. And so when you do this, keep in mind, I'm trying to show you guys that I clearly know what I'm doing. At that point, you can say ditto, okay? So when you're doing any quiz or any exam, as long as you at least show me one, you can then say ditto. I'm totally fine with that. With 3.9 and 4.27, let's get those in there. 3.90 out. Lim, shout them out.
Oh, I'm so writing.
4.52.
Oh. We went from paces, find it. Still writing. That's fine, it happens. Get some more coffee here because I can just like get hot coffee in the middle of class now. So funny, I'm still wearing my shirts though. I'm still wearing my funny shirts. Got to keep up the appearances like I'm still working here. Okay, does anybody have the pH at 30 for me?
4.52.
4.52 at 50.
4.97.
4.97, that makes sense. 60.
5.22.
5.22. Who's saying all these?
Kimchi.
Is that you?
5.59.
Is that you? Okay. So at this point, we should be able to make a plot. And so I'm going to have Dallas remember to go ahead and make a plot worthy of Mordor. So make a plot worthy of Mordor. Alice, look it up. Okay, so we know we're ending in the 9s. I'm going to go ahead and go a little bit above it. Oh, wait, hold on. I learned about this. Look who got all fancy over here. Oh. All right, so yeah, look at OneNote. If you guys aren't using OneNote and you guys are all tech savvy, this is pretty cool stuff, I'm telling you. By the way, this was my idea back in 1985, so I'm just saying I want some royalties here. So we're going to go volume of the base, and we went in increment 10. We'll go 10, 20, 30, 40, 50, 60, 70, 80. And our starting pH was actually pretty low, as I recall, like in the 3s or 2s.
2.42 or 2.4. Wait, hold on.
Okay.
Is it 7?
1, 2,
0.42.
Yeah, 2.42.
6, 7, 8, 9, 10. I'll go ahead and go to 11. This is our pH. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Wonder if I could have made that bigger. Probably fine, I guess.
You can highlight it all and just expand it.
I mean, I can hit this little circle thing, and I can go like this. good stuff. And again, if anyone is a OneNote master like Boudica and you guys see something I can do better, please help me. Or I shall become the student. Okay, so let's get some cool. Oh, what am I doing here? I'll do red dots here. Okay, so our initial was 2.42. And then we had at 10 mils was
3.90.
okay.
4.27.
Okay.
4.52.
4.52.
4.74.
4.74.
4.97.
4.97.
5.22.
5.22.
5.59.
5.59. Then we shot up to
9.14.
okay. And so
Why don't you increase your pen size so you can make those not scribbles?
because still sort of make some scribbles, maybe. Is that a little better? Maybe a little. Okay. I just want to make sure they're big enough that when you get the PDF, you can sort of see it. I just hope it's not when I go to like write now, it's going to be like, "Rawr!" So I'll have to go back and change when I make bullets to go back to a finer point for writing. Okay, so let's go ahead and sketch our little thing here. Our nice little blue pen will come up, and then we see we just skyrocket. And our middle point was what, 40? So I want to circle that. That was our midpoint. That was our halfway point. And again, we have this region right here. This is our buffer region, where the pH essentially is not changing much. It immediately jumps up and then sort of sticks. Now, there is one thing that I want to do to sort of show you something, and that is what happens, let's see. Am I already there? Hold on. I was trying to see, and you might as well just go ahead and do this now. What happens if I go 5 mils over? I'm going to ask that question here. What does it look like what does it look like at 5 mils over titration?
Wouldn't it just stay the same?
We're going to find it.
Around like 9?
We're going to find. Yeah, you think like, what's the big deal, right? Turns out it is a big deal. Okay, so when we are over titrating, that means we've gone too far. Now you guys remember your titrations from 110, 120, and we would always get to that end point, and we get to that one drop over, and we freak out because everything went crazy. Now, oh dear, I made this a 2-hour meeting. I hope it doesn't stop recording. Oh, we'll find out. If we suddenly get a thing that says that the meeting has stopped recording, I may have to start a new one to finish out this problem. So what happens at 5 mils over? When we did only 1 drop over, 2 drops over, the phenolphthalein went dark pink. We all freaked out. We're like, oh my gosh. Well, so this is way more than a few drops. And I want to see what happens at 5 mils of an over titration, if you will. So, okay, at the endpoint, right? Let's look at our endpoint. At our endpoint, What was our concentration of OH minus?
1.38 times 10 to the negative 5.
Yeah. 1.38 times 10 to the minus 5. Okay. That's not very much. What happens when we add 5 mils to this solution now? So let's add that 5 mils into the solution. Now add 5 mils, and it was NaOH or KOH? It was
KOH.
KOH. 5 mils of KOH to this endpoint solution. Okay, so if we look on our chart, we might as well go to 85 mils. So it's not really that much. We already have 140 mils of solution. We're not really adding that much more, but what does this actually happen? What we need to do now is look at the total number of moles of this OH that we now have. The AC minus has set up its own equilibrium, has generated that 1.38 times 10 to the minus 5 for the OH, and now we're going to continue to add more OH to this solution, which means it should get more and more basic. So if we do this 5 mils of KOH, and the KOH was, what, 0.6? So we have 0.6 moles per liter of the KOH. Oops, that's not a thing, that's a thingy. And we are going to add now 0.005 liters of the KOH, which really means there's 1 mole of KOH to every 1 mole of OH minus. Just proving the 1-to-1. You know, if you leave out that step, I get it. But now that 5 mils is in how much solution?
Is 140.
Yeah,
Right.
Dallas says increase. It's 140 at the end point. We added 5 more, so it's now 145.
Yeah.
This is now 0.145 liters of solution. So that's the 140 endpoint plus 5 mils added. Lim, you're on this.
I got 0.021.
0.021, and that's equal to the concentration of, so if that's OH minus, then what's our H plus? Ooh, whoa, get back here. If that's the OH minus, then our H plus is equal to 1 times 10 to the minus 14 divided by?
The number I got is 4.83 times 10 to the negative 13.
Oh man, I should have made this a little more on my scale. Oops, 0.021. All right, and that is the H plus. I think we're all big boys and girls. That means our pH is equal to 12 and change.
Yeah, 12.32.
Okay. So check it out. That means that actually, I need to come back over here. I need to actually make another one here for 12. I need to run over here, grab that mark, and go bonk. And now continue my trend to just jump straight up. You guys see how fast that jumped in only 5 mils? when we started doing these plots, I ended up, skyrocketing to the end point. Okay. Actually, Chef asked a question. So the addition of AC minus increases the OH, therefore the pH, it increases the pH. Actually, we're not adding the AC minus anymore. We're adding that base that we were titrating with. When we got to the end, Chef, we got rid of all the H pluses. The AC minuses finally got their chance at bat, okay? Because all of the big, bad, nasty, strong bases were gone, okay?
So then at this point, are we just adding more OH, right?
Now we're just adding ROH to what was a neutralized solution. There's no more HACs. There's no more H's anywhere to combat these OHs. So it's kind of like you did a bait and switch. You're like, you had your first string quarterback and you're like, oh, well, we might as well let the second string in. The second string gets in there, does a crappy job, and like, forget this, we're putting the first string right back in, and they take over and do their job again.
Oh, I get it, because in titrations, we're just trying to neutralize them. So then if we add just even a little more, it would just increase. It would basically make it really basic then.
Yeah, and in fact, truth be told, when we did one of these titrations for Chem 110, don't tell them this, we went ahead and you guys might remember from Chem 110 where we took the base and we standardized it against KHP. Then we used that base to titrate vinegar, okay? Josh and I were doing this titration. He standardized against the KHP. Then it was my turn to standardize against vinegar. Well, I forgot to grab vinegar. I grabbed salt water. So if you remember from the lab, the last lab we did, you guys were supposed to determine the pH of salt water. And I told you guys, don't worry about that. And why was that?
Do you want me to say it, or?
I guess so. You're the only one brave enough to get on a mic.
Oh, it's because nothing reacts, right? Or like it doesn't, like the equation doesn't make it like acidic, or it doesn't even like turn into like the basic equation. It's just salt water.
It's just salt water. There is no impetus for sodium to grab hydroxide and go backward to make the sodium hydroxide compound. It's a strong base. It's a very soluble salt. And so it's a one-way trip. It's the same with the chlorine. The chlorine is not a strong conjugate base. It will not grab the H's. It will not make HCl. HCl is a one-way trip. So because you dumped in some more sodiums and chlorides, the solution's like, great. So I have more of them. I'm not going to suck up OHs. I'm not going to suck up H pluses and pull them out of solution. Okay. So when I went and I grabbed the salt water to do the next titration, thinking it was vinegar, I got one drop into the titration and the whole solution turned pink. One drop. And at first I'm like, this is weird. So I grabbed the solution again, grabbed a brand new flask, thinking it was a bad flask. One drop, boom, it flashed pink. At which point Josh goes, let me smell that thing. It did not smell like vinegar. And we're like, so I went back, found the bottle that was actually vinegar, and it worked. One drop in a neutral solution will jump that pH ridiculously, like three steps. Just one drop to a neutral drop will jump it like 3 steps. Yeah, so once again, Dallas, it wasn't because the water was bad. It was because sodium and chloride will not go backward to make the compounds. Therefore, it just doesn't do anything. And remember, I told you, Dallas, the Henderson-Hasselbalch equation freaks out right near the end point, yes, but it's also moot when you go past the end point. Kimchi says, wait, so I'm still waiting. Kimchi says the concentration of OH we just found with the extra 5 mils, is that the new concentration of OH, or is it added to the OH from the endpoint? The answer is yes and yes, but keep in mind the endpoint was 10 to the minus 5, and we just added 021. So we are 1,000 times more concentrated. Your 1.38 times 10 to the minus 5 is a match on a fire. It just doesn't matter. It's just a drop in the bucket.
Right. Okay.
So Dallas. Oh, good. Yeah. So Dallas says basically the same thing if I understood correctly. I assume you did. And then Kimchi says technically the OH concentration is that. Yes. Yes. Technically you're right. But again, it just doesn't add anything. So, so this is kind of interesting. You notice, by the way, I also did put a little curve here at the end of it. I went ahead and let me do this. There's a little bit of a sloping out. If you were to continue this, you would notice that this would now sort of plateau off and just go off incrementally as you added more base, slowly approaching but never reaching the pH of the base solution. You could never reach that because you are continually diluting it from the initial stuff you had. But you get pretty close to what the pH would be of that KOH proper. Questions? All right, that one. Okay. All right, we've been at this longer than I thought. Man, I'm having too much fun. Aren't you guys?
Totally.
So what I want us to do is I could either do one more or I could send it back as homework and start with it at the next session. And maybe I'm going to go ahead and do that so that we can go a little more quickly through one more example and then do a quick little review of the quote, what is going on, because I think that's an important thing to do. We've been struggling with the what is going on type situation. So how about I give you guys a little homework, a little H-dub.
Oh, Aaron, I have a question. Is the question that you added at the end where it's like, oh, what would happen if we add 5 mils? Would that be on the exam?
All right, am I going to put that on the exam?
Most likely, right?
I want Tanaris to answer that.
Yes.
Yeah.
Yeah.
Right, because this makes a complete curve. And what you'll see is as we do this homework problem, I don't know, dude. Tanaris, of course, wants it as homework. He just wants to get out of here. Yeah, I'll go ahead and send this one home as homework. And then I'll quickly go through it at the beginning of next session. We'll do a quick review of the what is going on. We'll do another monoproduct just to really make sure we got it down before we move into polyproducts or more than 1H. And then after I give you this homework assignment, I'll ask you guys a couple questions about how this is going and how you want me to do office hours. So let's see. Let's do a homework assignment. So for you at home. How about 300 mils of 0.4 molar HF with 0.8 molar lithium hydroxide. And the Ka is equal to 3.53 times 10 to the minus 4. So we are going to be pushing it, but I'll say you could probably get by with neglecting X, even though we are pushing the envelope. I'm going to go ahead and note that. Note. Pushing the envelope. Go ahead. And you need to text.
So, quick question. Would you want us to send this to you in an email, or will you open up an assignment for this?
This isn't actually homework. What I'm saying is, please go home, try it. On Tuesday, I'm actually going to go very quickly through it. And so you should have it on some paper, or maybe if you're on OneNote, you already have it in OneNote, and you can follow along and say like, oh yeah, I did what he did, type thing, and stop me if you have a question. It's not true homework. It's just,
Okay.
Do you want us to go by 15, like 15 milliliters, or how?
Dallas was like, how many data points do you want? I mean, let's face it. What's our end point volume? You guys should be able to do this off the top of your head. You're going to whip out a calculator, aren't you, man?
Yeah.
What's 4 divided by 8?
2.
Well, what's 1/2 of 300?
150.
150. So the halfway point is
75.
75. So, Lim, you said what's a good increment?
15?
Why not? 50, 30, 45, 50, 60, 60, 75. That gives you a good 5 points on either side. That'll make a really nice curve.
Okay.
Dallas, I would not go by 10s or even 5s. While, I mean, it would be fun. You wouldn't want to do that on an exam. It'd be great, but there's a point at which you get diminishing returns. If you wanted to, Dallas, go ahead by 5s, because I know you know how to do this really fast. Because if you do that, you'll notice that we really jump up. Even in that first 5 mils, we will jump up near the buffer region pretty fast. And I want you, if you don't mind, Dallas, to have those numbers so we don't have to quickly whip them out, but to prove my point. Is that cool? Thank you. All right. Okay. Note, pushing the envelope, but go ahead and neglect X. And I would say that 15 is probably a good increment. All right. So I guess I'm going to and stop recording it, but then ask you guys some questions. Is that cool, or are there questions you think should be on this video still?
So the endpoint for that problem would be 300 mils or 150.
I think it's 150, right, guys?
Yeah.
Yeah. And in a sense, our base is twice the strength of our acid, so we need half as much.
Okay.
Will any of the titration curves require a shift in the ice table? No. Keep in mind, we're always assuming, Chef, that we are starting with that solution. It is, as we've done it now 3, 4, 5 times. If you're just getting the pH of a solution that's been sitting there, it does not require a shift in anything. The only time you'll have to do a shift of any sort is when I give you a bunch of ingredients.
Yeah. And then no.
And then say, what are you doing? Yeah. Does that make sense, Chef? Oh, she even raised her hand for that. Did that answer your question, Chef? Oh, well, yeah, okay, good. Who is this over here with their hand up? Kyra, did I answer your question?
Yes, got it.
Ferris, you had your hand up. I'm unmuting you, Ferris, so we can hear you. Maybe. Oh, I can't override and unmute you like that? Oh, I guess if you guys mute yourselves, I can't override it.
Yeah, I'm all good.
I can't force you to talk to me. Oh, man. I thought I was going to force participation here like I do in class. All right, any other like questions about this before I talk about how to do office hours and such? Seeing no.
One more question. So you said
All right.
100. You said the 150 mils is the endpoint because the base is twice the strength of the acid.
Yeah.
Okay.
Right. The candle that burns twice as bright burns half as long, so the base that is twice as concentrated needs half as much.
Okay.
Okay, I'm going to go ahead and stop this recording. Boonk. You want to stop?